Swayam Prabha. Digital India. Educated India.
Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you. This is the TQM 2 lecture number 5 and I am Raghunandan Sengupta from the IIT department, IIT Kanpur, and we have just given the 3 distributions. I know it is a little bit fast, but this would be repeated time and again. I am sure you will get adequate time to understand them in TQM 2. Number 2 reason why I am going a little bit fast is that this is not the general things which are needed in TQM2. Third reason is that people who are nowadays, statistics is an integral part in class 12 and some in schools and some colleges, they do give some concepts of probability in class 10 also, and obviously in engineering and non-engineering courses probability and statistics is a big part. So that is why these are precursors. I am sure you know that no proofs are required, only the results would be required in order to basically proceed for the design of experiment. So with this, let me continue. So what are the estimators and what are their properties? So but by the word estimators I mean that consider your population, there are some parameters. Parameters are technically scale parameters, location parameters, shape parameters, which gives you the first moment, second moment, third moment, fourth moment, which basically means something to do with the mean, median, and then the variance, dispersion and all these things. So these are the characteristics of the population. Now considering the characteristics of the populations are very important for us to find out. If we do not have their actual values, what we do is that we pick up a sample, find out from the sample characteristics and try to find out that whether using those sample characteristics we can find out something to do with the population parameters. So there we need estimators and the concept of estimation process would be required. So this is what we are discussing. So estimator is any statistic, a random function which is used to estimate the population parameter. So they can be either unbiased and they can be biased, and if they are unbiased, which technically means the average value of that, because that the estimator, if you are picking up sample time after time, the observations are different. If they are different, then the estimates would be different. Say for example, the sample mean would change, and if the sample mean keeps changing, obviously it will have a distribution. So hence it will have an expected value. And in the long run, if the expected value of the sample statistic is exactly equal to the population parameter, then obviously it means unbiased. But obviously it does not mean that the variance is high or low. So that would basically be coming out from the concept of consistency. So consistency means that how consistent the results are, and that means in the long run that as n the sample size increases, the difference between the sample estimate and the population parameter is less than some epsilon. Again this epsilon is some function of n, and then basically that n tends to 1 as n increases to infinity. So let me draw 2 diagrams. One diagram would be sufficient for all of us to understand. So this is the distribution, consider this is the distribution, and then another, and this is the mean value. Let me change the color. So this is one distribution, another one, obviously the mean value is same. So in this case, expected value of this green line, so the green line is whatever the parameter is basically equal to theta. In the second case, the expected value of the red line is equal to theta. Theta is basically this line which we want here. To give me 1 minute, let me change the color, it will be easier for me. So this is the mean. Now very interesting thing you understand is the variance which is there. The dispersion in this case and the dispersion which is happening in this case are two different values, which means as I increase the sample size, the difference between the expected value and the variance basically closes. That means the mod. So, each n the sample size would give me different statistic. So, as I increase the sample size, the difference between that actual sample statistic and the population parameter will start decreasing. So, this would be some concept which we are studying. So, this is something to do with the variance, and if I change the color, this is something to do with the variance, and so the concept of the variance would be coming out here. So, let me use a highlighter. So, the highlighter this is to do with this, something to do with this, and if I use the highlighter, let me change the color. Violet, should it look good? Let me try. So, this is the one. So, this would something to do with this. So, they are related. So, I am just trying to make you understand that what is the concept of the unbiasedness and consistency. So, for the discrete distribution, if it is uniform between A and B, then A is basically the best estimate would be the minimum of x1 to xn, and for B estimates. So, the hat means the estimates which you have, not the actual values. So, A is best estimate is A hat, which is the minimum value between x1 to xn, but it does not mean say anything about the consistency and unbiasedness. And B's best estimate is B hat, which is the maximum between x1 and xn. So, intuitively is very easy to understand. Say for example, I have a box and there are chits marked, say for example, million of them, 1 to 1 million, and I do not know what is the minimum value, and what is the maximum value. So, consider theoretically the minimum value is 1, maximum value is 1 million. I need to find it out. What I do? I pick up a sample of 100 randomly. I pick up and note them down, find out the minimum, note it down separately, find out the maximum, note it down separately. So, I continue picking up 100 observations time after time with replacement. So, if I have different minimums for each set of samples which I pick up 100 in number, if I have different maximums for different samples which I pick it up, if I find out the minimum of that minimum and maximum of the maximum, that in the long run would basically give me some information about the minimum of the total population, which is 1, and maximum of the total population is 1 million. So, that is basically some essence or what I mean, that actually that I have tried to find out the minimum of the maximum of the observations. Now, if x is binomial with parameters n and p, then p hat, or which is the best estimate of p, is the number of favoring or number of unfavoring. So, if it is q, I need to find out, it will be the number of unfavorables divided by n, and if it is p, which is p hats is the best estimate for that, then it would be the number of favoring one divided by n. And if it is basically the Poisson distribution, which is the lambda, then the best estimate for that lambda would basically be lambda hat, which is again equal to the sample mean. So, this we already have. Now, if we come to the case of estimators for the continuous distribution, consider x is normally distributed between mu and sigma square. So, best estimate for the mean is x bar n, which is the sample mean. Now, in the case when you want to find out the variance, best estimate the variance, there are two cases if you remember, S dash and S dash, S without the dash. S dash is the case when you have the population mean is known, hence you do not divide by n minus 1, you only divide by n, and then you find out the best estimate for the standard deviation on the best estimate of the population variance. In case if mean is not known, you replace that with the sample mean, you lose 1 degrees of freedom, hence it is divided by the total value is divided by 1 by n minus 1, and that is the best estimate for the population variance. For the case when you have the exponential distribution without the value of a, so there is only one parameter of theta, so the best estimate for the theta is basically the sample mean. So, example, it is found out the respective numbers of members in 10 different families are 4, 5, 6 until 6. If we consider that the number of members in a family to be uniformly distributed, then the estimated value of A and B would be A and B, as we just discussed how they can be found out. You are testing the components coming out of the shop floor and find out 9 out of 30 components fail, then the estimated value of P, which is the proportions of bad items, or it can be the proportions, Q can be the proportions of bad items, it is just the nomenclature what we are using, that would be the N by 30, which is the proportions of the chance or the relative frequency, and in the long run it is the probability. At a particular tailor machine in one of the bank branches, it is found that the number of customers arriving in a unit time span, whatever the unit time span may be 1 minute, 1 hour, 3 minutes, 5 minutes, whatever it is. The numbers are 4, 6, 7 till the number 5, then they are Poisson distributed. If you find out the distribution of the numbers, then the estimated value of lambda, which is the parameter for the Poisson distribution, would be the sample mean. So, which means you add up all these values, divide by the total number of readings, you get the value of 5. Then considering the exponential distribution, suppose it is known that the survival time of a particular type of bulb has the exponential distribution. You test 10 such bulbs and find out their survival time to be 150, 225 till the value of 400. So, there are 10 such examples. Then I want to find out theta, which is the parameter for the exponential distribution. Best estimate is the sample mean. What you do is that add up all the values starting from 150 to 400, divide by 10, and you get the value of 202. So, with this I would not end. So, what I will do is that I will start off the concept of estimation more in general, and then go into the point estimation concept and the hypothesis testing. This would basically end the preliminary portion, and then we can go into the actual design of experiments. So, there are some interesting results which we may have gone through some of the results very preliminary, but please bear with me. As I progress, you will find out the overall expanse of what we want to discuss is much more, and this would become really make some sense in our discussion as we go into the later chapters for design of experiment, which is a part and parcel and a big area of TQM2. So, consider if x1 to xm xn, and there are n number of random variables such that each time we have their realized values are given by x1j, x2j, x3j till xnj, xj, j suffix basically means the time when you are picking up. So, say for example, you are picking up and the random variables are technically before you pick up they are x1 to xn. When you pick up they becomes x11 suffix 1, the first one is for the reading number, second one is basically for the person. Second reading for you would be x21, 2 for the number of the reading, for the second one is basically for the person. So, if you pick up, so they are x11, x21, x31 till xn1. If I pick up, I am the second person, my readings are basically again it will basically x12, x22, x32 and so on and so forth. So, there would be j number of persons who can pick up, and hence the suffix are given by x1j, x2j and so on and so forth, for j being the number of such samples we take. Now, if x is distributed and normal with mu and sigma square, then obviously the sum which is S which we have discussed, that is why I said that I will be repeating few things, but I will be going not in depth, but trying to repeat it in order to make it make much better sense to you all. So, the sum of the n number of random variables which are all normal, and that mean value would be n mu and the variance would be n sigma square. And in the case if you need to find out the sample mean, then the sample mean will be distributed again with normal, with mu as the mean value and sigma square by n as the variance. And if we convert them into the corresponding standard normal, for x would be, let me repeat it one by one. So, x would be distributed as z, where z will be given by x minus mu divided by sigma. In the case when you are trying to find out the standard variable, the standard variate with corresponding to x bar n, it will be x bar n minus mu divided by sigma by square root of n, as it is given where I am hovering my finger. So, I will try to basically highlight it. So, okay, let me give the color, it will be difficult for, oh, this is not PPT, so I have to basically use some color if possible. So, this would be the case where I want to highlight, and if you find out, so this is I am using the yellow color, and so this would be normally distributed standard normal with mean for x bar n as mu and variance was sigma square by n. Similarly, you can do all the calculations corresponding to finding on the standard normal. Now, I did also mention about S dash and S without a dash. So, S dash and S without a dash are basically the case where we take for the the variance of the sample. So, these are the values. S dash is where you do not lose any degrees of freedom because the population mean is known. S without the dash is basically the population mean is unknown, you replace that with the sample mean. So, hence it is divided by n minus 1. So, result 1 would be, which I have already repeated, I will repeat it again. The distribution of the ratio of S dash square by sigma square, and obviously n and n minus 1 would come or corresponding to how you do that. It will be given by chi square with n degrees of freedom, and the ratio of S without the dash sigma square multiplied by n minus 1 would be given as the distribution chi square with n minus 1 degrees of freedom. So, here we see that we lose 1 degrees of freedom due to the fact that the mean value which is to be found out for as the best estimate for the population mean is given by the sum of all the random variables divided by n. Random variables, which means which you are picking up for the sample, divided by n, which is the sample size. Note, for a normal distribution, x bar and s square are the sample mean and the sample variances, and they are distributed normally, and chi square and chi square n minus 1 are these are the corresponding distributions which we find out corresponding to the case when the population mean mu is known and unknown. If it is known, we do not lose any degrees of freedom. If it is unknown, we lose 1 degrees of freedom. The second result, which is again very intuitive, because we remember that T distribution is given by a ratio of Z, which is with Z distribution divided by square root of chi square by n. So, this is the same thing. So, if you see this, where I am hovering my pen, or where I should basically hovering the cursor, this numerator is basically a standard normal distribution, and the denominator you have two parts. One is the chi square, this one, and this is divided by degrees of freedom. So, the ratio is technically a Z distribution divided by square root of chi square divided by its standard degrees of freedom, and once you basically make sense of that, it becomes a T distribution with n minus 1 degrees of freedom. In cases n is large, then it can be approximated by a standard normal distribution, because you remember that the T distribution has a mean value of 0, and as n basically increases, it can be approximated by a normal case. Result 3. So, these are important results. Result 3 is that, consider you have two different set of observations. Consider, to give a very simple example, consider there are two factories manufacturing the same items. One is in Chennai, another is Bangalore, or one is in Delhi, one is, say for example, Patna, whatever it is. And you want to basically find out that what is the variability of the production. Variability of production can be related to the ductility of the material, may be related to the tensile strength, may be related to the length, may be related to the inner dimension, may be related to the viscosity, whatever it is. So, assume x1 to xm, m as in mango, are the number of random variables you are picking up from the first set, and its basic distribution is normal with mu 1 and sigma 1 square are as its basically mean and variance, and the value realized values, depending on if they are the jth number being picked up, they would be x small x, because they are the realized values, small x 1j, small x x2j, x3j, so on and so forth. So, if you are picking up, you are the first person you are picking up, it will be x11, for me it will basically be x12, and so on and so forth. So, it is very simple nomenclature. The first one is the reading number, second one is the person who is picking up, or which time you are picking up. So, y1 to yn, n as in Nagpur, is the number of random variables being drawn from y, which is normally distributed with sigma 2, as square is the variance, and mu 2 as is normal value, population value, expected value, such that the observations are again y1 k is the number of reading you are picking up, as it is j in x. So, here mean values are, for the sample is x bar m, and for y it is y bar m n, and the standard error or the variance of the sample are respect to two cases. Case 1, population mean is known for x and population mean is not known for x. Another case is population mean for y is known, population mean for y is not known. So, obviously, there would be s dashes in both the cases, s dashes without in both the cases, but only to differentiate that s dashes, you will put the suffix corresponding to the sample size which you is calculating, which will become very evident from you. here. So, if you consider this, let me color it for our simplicity. So, this is for M and this is for N. So, now see here they are both the dashes. So, they do not lose the degrees of freedom. For the other case it is N M, but without the dash, again without the dash N. So, if you compare them you will understand. So, in the first case when we find out you have a chi-square with m degrees of freedom. So, this will basically denote by this yellow color. So, this has become apparent to you. So, I am just highlighting, and this would become the chi-square with 1 degrees of freedom being lost. So, this ratios would give you the y, because you are trying to find out the population mean using its sample mean. Now, if I come to find out, these results have been repeated, but please forgive me, I am trying to repeat it time and again because they would be very relevant later on. So, if I want to find out the ratios of the standard error whole square or the standard sample variance for the sample, and considering it is S dash. So, if I find out if it becomes F m comma n, no loss of degrees of freedom for the F distribution, and in this case it will be F m minus 1 n minus 1. So, their relevance is where I am hovering my cursor. So, this is dash, I do not lose any degrees of freedom. This is without the dash, this is without the dash because I have lost degrees of freedom. So, that is why they are a m minus 1 n minus 1. Now, continuing our discussion, maybe a little bit more philosophical discussion, we consider a set of n observations x1 to xn. They are set and they say that we find two estimates. Consider we find two estimates given the population. So, we pick up a set of observations x1 to xn, and consider from them we can find out two functions, or consider two values. So, name them as the statistic t. T is not the t distribution, remember that, t suffix n1 and t suffix n2. So, this 1 and 2 are not the suffixes of n by itself, they are n comma 1, n comma 2. So, n remains the sample size, 1 and 2 which is the second number after the n basically denotes the two values. So, they are basically used to estimate the population parameter theta. Moreover, we are interested to find out given a level of confidence. So, this level of confidence would basically mean that to what level of significance are you certain that the answer is correct. So, say for example, if I am saying that I am 95% confidence, it means that if I pick up 100 observations, 95 a number of them would be true. So, obviously, my level of confidence would differ depending on what type of observations we are picking up and depending on the experiment we are doing. So, this 1 minus alpha would be the level of confidence that we are sure that the value of the parameter, which by itself is a constant, lies in the random interval range between these two numbers which you have found out, which is t suffix n comma 1, t suffix n comma 2. Now, remember t n comma 1 and t n comma 2, this n 1 and n 2 are suffixes. The overall random points which are picked up from the observations, which are still n in number, but we are combining them in such ratios that the values are different. So, this diagram will make sense, some sense. So, if you consider the diagram here, the theta, which is the blue line, is fixed, and when I pick up observations depending on whether it is the first one, second one, third one. So, for example, you pick up observations and they are different from my observations, you find out one minimum value, one maximum value, and these minimum and maximum values are given by t n 1 comma 1, t n 2 comma 1. So, this basically the second one basically means the person, and the first 1 and 2 basically means the lower value and the higher value. If I pick up the observations, in my case they would be, again the sample size is same, which is n, they would be as basically be n t suffix n comma 1 comma 2, and the higher values would be t suffix n 2 comma 2, where the first 1 and 2 are basically the minimum and the maximum value, and the second 2 is basically the number is picking up. So, from there we find out that given the level of confidence, we will find out that the probability that the lower values and the upper values would contain the value of theta with a level of confidence which we just mentioned as 1 minus alpha, which means that if I am say that I am 95% confidence level, it will mean that the minimum and the maximum value which I find out from the sample set of observations and give the minimum and a maximum value whatever it is, the statistic, they would contain in that interval the value of theta, which is the population parameter. So, this means that Tn1 and Tn2, the difference between them, that is the maximum or the higher and the minus the lower value, would give me the confidence interval which has the parameter theta inside it with the probability of 1 minus alpha. So, consider the interval of mu when sigma is known. So, consider when sigma is known, the z distribution is obviously basically x bar suffix n minus mu divided by sigma by square root of n would be z distribution. So, once it is z distribution and considering sigma is known, then if you find out the minimum and the maximum value, they would basically be given from the z table depending on the level of confidence which we have. So, the minimum value would be z suffix 1 minus alpha by 2. So, now listen to me carefully. So, the suffixes r basically denotes to where the random variable which you are measuring are. So, if I consider the x line as with the values where I am denoting the z. So, z would basically be coming, it would be a negative from my side, there is a mean value 0, on the left is 0, on the right is positive. So, the values which I take on the left would be denoted by z suffix 1 minus alpha by 2. So, 1 minus alpha by 2 is the area still to be covered, and once I basically go on to the right hand side, it will be z alpha by 2, that means the area to be still covered is alpha and the area already covered is 1 minus alpha by 2. Now, as it is symmetric, hence the values, not the with the sign, the mod values of z suffix 1 minus alpha by 2 and z suffix alpha by 2 would be same, but they would be a different values corresponding to the fact that the minus sign for the left hand side. So, they basically we denote, as I mentioned and I highlighted this. So, this value of minus z alpha by 2 basically corresponds to the case of z 1 minus alpha by 2 and this z alpha by 2 remains the same. So, if you do some simple algebraic, not very complicated, just we take from the denominator to the numerator and multiply all these values. The final answer which comes out, which is very important for us to note down and will make a significance later on, is the Tn1, which is the lower value which he said is basically x bar n minus z alpha by 2, this suffix multiplied by sigma by square root of n, that is the Tn1 value, the statistics of the lower value, and the other case the higher value would be x bar n plus z alpha by 2 into sigma by square root of n. Now, the difference between them would basically given by twice of z alpha by 2, because in that case x bar and x bar n would cancel out. So, it will be twice z alpha by 2 sigma by square root of n, and that will give me the total confidence level length. We see the interval between T1 and T2. T1 and T2 I am basically using in a very short form to denote Tn1 and Tn2 is random, but the probability that the interval will contain. So, the difference is fixed, random in the sense the values would be changing. So, it is like this, if I denote the Tn1 as the left hand this finger and the Tn2 as this value, they themselves will be shifting depending on the sample observations which I am taking, but the length between them always remains fixed. So, hence the probability that this interval will contain the population parameter, in this case, the expected value mu or theta is given by 1 minus alpha, and we can do the calculations accordingly. Remember, the distance between Tn1 and Tn2 is the shortest distance, and such that it contains the parameter mu with probability 1 minus alpha. Now, if I want to find out the case of the value or the confidence interval of the Tn1 and Tn2 value for mu given sigma is not known, then the whole concept changes. Now, before I discuss, let me again come back to the distributions which we have discussed. Distributions we have discussed was the Z distribution, T distribution, chi-square and F. Now, here one thing should be remembered, which I thought I would make it clear beforehand. Whenever you are doing some studies related to the mean value, it has to be either the Z distribution or the T distribution, with degrees of freedom being modified accordingly. And whenever it is to do with the sample variance with respect to the population variance, in the distribution has to be chi-square or F distribution. So, chi-square with the loss of degrees of freedom as and when required, or F distribution with the loss of degrees freedom from M and N as required, depending on the calculation. So, with this I will close this lecture and continue to the last part of the general preliminaries, then start with the degrees of freedom and concepts of TQM in more details. Have a nice day. Thank you very much.